Section 4.4 is least common multiple. I can find the least common multiple of two numbers. A multiple of a whole number is the product of the number and any non-zero number. A multiple that is shared by two or more numbers is a common multiple. Some of the common multiples of 8 and 12 are shown in blue. So here, multiples of 8 are numbers that we multiply to. So 8 times 1, 8 times 2, 8 times 3, 8 times 4, and so on. Multiples of 12 are the same thing, 12 times 1, 12 times 2, 12 times 3, 12 times 4. And if you see, these numbers go on and on and on. So where we talked about a greatest common factor before, it was the biggest number that multiplied into both of them because there were a finite or a limited number of options. But here with multiples, we can keep going on forever and ever and ever. So the thing that's most important here is the least one. So common multiples here, the least would be 24, and we'll talk about that more here in just a second. So, like I just mentioned, the least of the common multiples of two or more numbers is called our least common multiple, and that's important. Between 8 and 12 is 24. We can find the least common multiples of two numbers by either listing the multiples and comparing them, or by using prime factorization. So again, I'm going to use the prime factorization because we can list out multiples forever, and it might take a really long time to find them that way. So I'm going to use prime factorization. Least common multiples are really helpful when we're doing work with fractions, for example. So you're going to want to have this down. So for the least common multiple of 6 and 10, the first thing I'm going to do is find my prime factorization. So 6 is 2 times 3, 10 is 2 times 5. 2 prime, 3 prime, 5 prime. So when I list these out, I have 2 times 3, and 10, I have a 2 in my 2 column, and a 5. I'm going to find my greatest common factor first. I'm going to take that greatest common factor, and I'm going to multiply by every other column. So times 3 times 5. So 2 times 3 times 5 is going to be 30, and that's my LCM. Feel free to pause here and give this a try. Again, the first thing I'm going to do is find my prime factorization. I want to know what all of my factors are because factors are things that multiply to my numbers, and my least common multiples are the numbers that these multiply to. So we're really just multiplying the multipliers. So 16 is 4 times 4. 24 is 4 times 6. Those are all composites. I break them down further. 4 is 2 times 2, and 2 times 2, and 2 times 3 for 6. All of these are prime. So I'm done with my factor trees. And I'm going to list my factors. So for 16, I have 2 times 2 times 2 times 2. For 24, I have 2 times 2 times 2 times 3. My greatest common factor is going to be 2 times 2 times 2, which is 8. I take my greatest common factor because all of those factors have to be included, and I multiply by what's different, every other factor. So here I have a 2 and a 3. And those are my extra factors that I need to include in order to get to the number that both 16 and 24 would multiply to. The 8's included in both of them. We only need it once in order to get to the smallest one. But we still need that 2 and the 3 here. We get 48 is our least common multiple. That's the smallest number that both 16 and 24 multiply to. Try 2, please. So between 20 and 25, I'm going to do a factor tree for each. 4 times 5 and 5 times 5. 4 is 2 times 2. 5 is prime. 2 is prime. So 20 is going to be 2 times 2 times 5. And 25 is going to be 5 times 5. My greatest common factor is 5. So I take my common factor and I multiply by everything that's left, all of my things that are individual to my numbers, because those have to be included if we're multiplying using those values. So here, I'm going to get 100, and that's my least common multiple. So it's the pieces that are the same, but just once, my greatest common factor. And then every piece from the individual numbers we need as well. So we multiply all those together, and between 20 and 25, my least common multiple is 100. So the smallest number they both multiply to is 100. Here we have 6, 8, and 20. 6 is 2 times 3. 8 is 2 times 4. 20 is 4 times 5. 2, 3, 2. I can break down that 4. I can break down this 4. 5 is prime. Here, 6 is 2 times 3. 8 is 2 times 2 times 2. And 20 is 2 times 2 times 5. My greatest common factor is 2. I take that 2 and I multiply it by all of my other columns. I have another 2. This column has 2 2's in it, but that's okay. 3 and 5. So my greatest common factor here, 120. Not my greatest common factor, my least common multiple. Sorry. My least common multiple is 120. So if you see here, guys, we're actually just multiplying all of our columns. Least common multiple means we multiply our columns together. So my greatest common factor column is in purple, and my pink columns are everything else. But if you look, I took 2 times 2 times 2 times 3 times 5. Up here, I took my greatest common factor column in purple. The rest are in pink, but it's still 2 times 2 times 5 times 5. Greatest common factors are purple, so I took 2 times 2 times 2, and then times my 2 and my 3 columns. So we're actually just multiplying all of our columns together. Okay, so least common multiple means we're going to multiply our columns. 15, 30, and 50. I'm going to find my factors. 3 times 5, 5 times 6, 5 times 10. 3 and 5 are prime. My 6 is 2 times 3. 10 is 2 times 5. And those are all prime now as well. So I can write my values in factored form. 15, 3 times 5. 30, 2 times 3 times 5. And 50, 2 times 5 times 5. So here, my greatest common factor is a 5. I take that 5 and I multiply it by the rest of my columns. 2, 3, 5. So only the 5 column is my greatest common factor because it's in all of them. And it doesn't matter that I have 2 2s and 2 3s. We just multiply by the columns themselves, each factor. And here I'm going to get 150. So 150 is the smallest number that all 15, 30, and 50 go into. That's my least common multiple. In example 2, here we have monomials, but we're going to do it the same way. So 9 and 15, I'm going to work with my numbers first. 9 is 3 times 3, 15 is 3 times 5. 3's are prime, so is 5. So 9xy squared is going to be 3 times 3 times 1x, y squared is y times y, base times itself, and 15x squared y, 15 is 3, make a 5 column, x squared, I have 1x here, I'm going to put the last one at the end, and 1y. So my greatest common factor, 3x, y, I take that 3xy and I multiply it by the rest of my columns. 5 times 3 times y times x. And here, 3 times 5 times 3 is 45. X times x is x squared. Y times y is y squared. And that's my least common multiple. So again, we can get there as well by just multiplying each of our columns. 5 times 3 times 3 times x times y times y times x. 5 times 3 times 3 is 45. X squared, y squared as well. The least common denominator of 2 or more fractions is the least common multiple of the denominators. And this is how the reason that least common multiples are so important, as they help us add and subtract and reduce fractions. So we can use least common denominators to compare and order fractions as well. Last year, a winter resort had 144,000 visitors, including 45,000 snowboarders. This year, the resort had 160,000 visitors, including 56,000 snowboarders. In what year was the fraction of snowboarders greater? So, as far as our fraction of snowboarders, we want snowboarders compared to the total people. So, last year, snowboarders was 45,000 compared to 144,000. This year, snowboarders was 56,000 out of 160,000. So let's try and reduce these fractions first of all. It might not be the greatest common factor, but I can see that there's 1,000 that goes into each of these. So I'm going to divide by 1,000. And that's going to give us some smaller numbers to work with, because each of these have those 3 zeros at the end, so I can divide by 1,000. I'm going to get 45 over 144 and 56 over 160. I went ahead and wrote out our prime factorization and in factored form for our fractions here. In our last year, we can see that our common factors are 3 times 3, which means 9 is my greatest common factor. So I can divide my numerator and my denominator by 9, which gives me 5 over 16. And 8 is my greatest common factor in the second. So when I divide out the 8, I'm left with 7 over 20. Here I found our least common multiple to be 80. And I can see that the 16 was multiplied by a 5 to get to 80. And my 20 needs to be multiplied by the 2 2's or the 4 to get to 80. And if I change my denominator, I have to change my numerator. So here I get 25 over 80, 28 over 80, and this year has more. I changed my denominator and my numerator, simplified